This video is continuing from the last one because I lost track of time. And we'll carry on with the problems with the combustion of hydrocarbon fuels. We'll look at sulfur dioxide and nitrogen oxides. So actually it kind of makes sense to split the two up because these ones in black here, carbon dioxide, monoxide, carbon and unburnt hydrocarbons, are direct products from combustion because they are from the fuel burning itself. Sulfur dioxide and nitrogen oxides are a little bit more complicated. Now, hydrocarbon fuels are fossil fuels. They're formed from the anoxic decay or anaerobic decay of living organisms over millions of years. Many proteins, as you may know, contain sulfur. Now, as do other tissues from the body. So when we produce when a fossil fuel is produced, we don't produce them. When a fossil fuel is formed over millions of years, sulfur impurities exist in the fuel. So sulfur is an impurity in fossil fuels. Now that's an important statement because knowing that sulfur is an impurity is usually one mark at GCSE. When you combust the fuel, any sulfur impurities that are also contained within the fuel that you haven't removed, because it can be quite hard and expensive to remove before you burn the fuel, the sulfur will react with oxygen to produce sulfur dioxide. Sulfur dioxide is quite a nasty gas. This gas can dissolve after it's gone off into the atmosphere. As it rises up in the atmosphere, it will then dissolve in a raindrop. Now, in the raindrop, and following a little bit more oxidation, sulfur dioxide, the gas, can react with water and a little bit of oxygen to produce our old favourite H2SO4, sulfuric acid. Now, there's a pickle. Sulfuric acid is a strong acid. It is a diprotic strong acid. This raindrop now contains sulfuric acid. That raindrop is now an acid raindrop. All rain is slightly acidic due to the carbon dioxide that dissolves in them, but acid rain contains a lower pH, even more acidic in nature than normal rain. Now, acid rain has a few problems. So it's a two-step process to begin with. The impurity burns and produces sulfur dioxide. Sulfur dioxide dissolves in the raindrops and produces acid rain. The problems about acid rain. Carbonate rocks, so anything made of chalk or marble, etc., they basically are chemically eroded, chemically destroyed. They react with acid rain, they are destroyed. So any buildings or statues that are made of carbonates, marble statues, calcium carbonate, chalk, all of that gets destroyed. Also, it can damage the roots of plants. Leaves aren't too badly affected because leaves have a waxy cuticle. They've got quite good protection on top of their leaves. The roots, however, have very little protection from an acidic substance. So if soil becomes acidic, the roots in particular can get damaged. If the roots get damaged, the plant will eventually die. It can acidify lakes, and anything that lives in this lake, any aquatic organisms, they can die as well. Particularly if you think about a fish, the fish gills, the gills have very little protection so that gas exchange can happen efficiently. Therefore, acid will damage the gills. It's like if you get lemon juice in a cup that you may have, putting acid in the gills of a fish will be very painful and will cause a lot of damage. Furthermore, another good example that can happen is that certain nutrients in the soil can get leached. They are basically, they get mobilized. They basically react with sulfuric acid and they can get leached out of the soil. So sulfur, the impurity in fossil fuels, not great. Now for some NOxes. Now nitrogen oxides, again, are pretty nasty. But there's a very different reason for why nitrogen oxides are formed. Sulfur, impurity. Nitrogen comes from the air in an engine. So NOxes, nitrogen is a very inert gas. It doesn't react much, it's unreactive. The reason that 78% of everything around you right now is nitrogen, it's very unreactive, it doesn't react much because there's a nitrogen-nitrogen triple bond. That bond is strong. So that bond is a strong bond. If a strong bond is within a molecule, it can mean that that molecule doesn't react, because in order for it to react, you've got to break that bond first. Anyway, in an engine, when you have your hydrocarbon fuel combusting, engines are pretty hot places. And under this high temperature, the nitrogen-nitrogen triple bond can break. So the heat of an engine, the heat or the temperature in the engine, the heat of an engine allows nitrogen to react with oxygen. Nitrogen from the air, because it's 78% of air. Oxygen is also from the air. So you produce nitrogen oxides. Diesel fuel burns at a higher temperature than petrol fuel. So petrol cars don't produce as much nitrogen dioxide or nitrogen oxides as a diesel car does. So nitrogen reacts with oxygen. I'll give you a bit of an equation here to give you NOx. You could be asked to write an equation producing a particular, let's say, nitrogen dioxide, like so. So half a nitrogen molecule, or half a mole of nitrogen reacts with 1 mole of oxygen to make nitrogen dioxide. But there are many, many nitrogen oxides. Problems with nitrogen oxides are as follows. Nitrogen oxide, again, or nitrogen oxides, they can contribute to the formation of nitric acid in raindrops, which is another contributory factor that forms acid rain. And then we have the same problems with this form of acid rain as we did with a sulfuric acid rain. Nitrogen oxides also can trigger respiratory conditions. And they can also trigger photochemical smog. Smog being a mixture of like smoke and fog. They